This is the review for the quadratics cumulative exam. We will be going over everything we've talked about regarding quadratics and parabolas. Number 1 says, what are the roots of the equation y equals x squared minus 6x plus 5? Remember that roots means the same thing as x-intercepts. We have multiple ways that we can solve this. We can solve by factoring. We can use the quadratic formula. Or we can graph in our calculator. I'm going to graph this in my calculator to find the roots or the x-intercepts. I go to y equals on my calculator. I'm going to type in my equation, y equals x squared minus x squared minus 6x plus 5, and take a look at the graph. I can see all my answer choices are whole numbers, so I can count on my graph. I can see that one of my x-intercepts is at x equals 1. I'm going to go ahead and cross off any answer choices that don't have positive 1. That would be A and D. And my other x-intercept is at 1, 2, 3, 4, and 5. So my roots or my solutions or x-intercepts for this equation are x equals 1 and x equals 5. That would be option B. Number 2, the table shows the x and y values of a quadratic equation. According to this, which of the following are most likely to be the factors for this equation? Okay. Remember that factors are what we get when we have an equation that's in standard form, and we factor it, and we can then take our factors to get our roots. So that means that whatever are in our factors are opposite of what we get when we solve to find our roots. Roots mean the same thing as x-intercepts. We know for all x-intercepts, the y value is 0. So here, my x-intercepts are 2 and 4. This means that my factors need to be the opposite, negative 2 and negative 4. This ensures that if we were to solve each of these equations, x minus 2 equals 0, and x minus 4 equals 0, that we would get x equals 2 and x equals 4 for our roots, for our x-intercepts. So I need x minus 2 and x minus 4 for my factors. That would be option B. Number 3, what values of x satisfy the equation x squared plus x equals 6? Okay, when we're looking for what values of x satisfy the equation, we are looking for the solutions. And remember, solutions is another word for x-intercepts. So I can graph this in my calculator. However, in order to graph, we need to be in standard form. We need to make sure that our equation equals 0. To make this equation equal 0, I need to move my 6. So I'm going to subtract 6 on both sides. And I get x squared plus x minus 6 equals 0. Now this is something I can graph in my calculator to find the roots. X squared plus x minus 6. Graph. I can see that all of my solutions are whole numbers, so I'm just going to count on my graph. My first solution, negative 1, negative 2, negative 3. My second solution, x equals positive 1, positive 2. So note on our answer choices these little curly Q brackets. These brackets denote that these are two separate answers. These are not ordered pairs. So these are my two x-intercepts, negative 3 and 2. option B. You could also solve this equation by factoring. You would look for a product of -6 and a sum of 1, which would be 3 and -2. From there you would fill in your box, +3 and -2. And you would get in your first column x plus 3 and x minus 2. Then you could solve each of these factors by setting it equal to 0, and you would get the exact same thing we got for our answer. Number 4. Given a situation that is modeled by f of x equals x squared minus 2, what happens to the range if 6 is added to the function? Okay, we have a parabola, and it says we add 6 to the function. So my new function would be, I'm going to call it g of x. That way we can differentiate. G of x equals x squared -2 plus 6 is +4. So if I look at this on a graph, I'm going to graph my original function, x squared minus 2. My new function, x squared plus 4. We want to know what happens to the range, or the y values. Remember on your calculator, if you use your left arrow key to go all the way over, you can make this line thicker, so we can tell the difference between our old and our new. There's my original. Here's my new. I can see on my calculator that my graph went up. Choice A says the minimum value is increased by 4. Okay. Minimum value, so the bottom of the graph, the vertex, is increased by 4. Our graph went up to 4. However, it says we added 6. So we didn't add 4, so it can't be A. The minimum value is increased by 6. That's true. We added 6 to the function. Increased means to add. The minimum value is 8. We don't have an 8 anywhere. It does not change. Our graph definitely changed from looking at our calculator. So the correct answer has to be B. Flip over, take a look at number 5. John used the quadratic equation to find the solution to the equation 3x squared plus 12 equals 5 by listing his steps below. Okay, we know a few things. We know, first of all, that to even work with this equation, we need to be in standard form. So we need to make it say equals 0. For this equation, that means I would need to move the positive 5 to the other side by subtracting. 5 minus 5 is 0. I subtract 5 on the left side. Notice here, 3x squared, that 12 and minus 5, those are like terms because neither one has an x. So 12 minus 5 gives me positive 7. I have equals 0. If we know that standard form is ax squared plus bx plus c equals 0, we can find our a, b, and c values. In this problem, we could say that a equals 3. B is the number in front of x. There's no x here, so that means b has to be 0. There's nothing there. And c equals 7. In the question, it said he used the quadratic equation, the quadratic formula. This is on your formula chart. The quadratic formula is x equals negative b. And remember, I like to put my letters in parentheses because that reminds me where I'm going to put a number. Plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. When we use the quadratic formula, all we have to do is take our values for a, b, and c and plug them in to our equation. We know that b is 0. So at the beginning, I would have 0 plus or minus the square root b squared minus 4 times a is 3, times c, so times 7, all divided by 2 times our a value. Let's look at what John in our problem did. Step 1. In step 1, John has negative 12 plus or minus the square root of 12 squared minus 4 times 3 times 5 divided by 2 times 3. Notice this does not match what we have. We have that the b value is 0. So already John has made a mistake. It says, which step does the first error occur? You can say his first error occurred in step 1. If you were going to continue working this problem out, then you would, in your calculator, put the part that is inside the radical. So I would put in my calculator 0 squared minus 4 times 3 times 7 to get negative 84. So to get x equals 0, positive or negative, the square root of negative 84, divided by 2 times 3 is 6. Okay, so if you had one like this on your test, you could keep working it out to continue trying to find where the mistake is. Moving on to number 6, what is the range of negative x squared minus 2x plus 3? Okay, we know from a negative that this graph is going to open down, so that means our y values are getting smaller. Y is less than or equal to. But we don't know what the vertex is. So let's use our calculator to graph this. Negative x squared minus 2x plus 3. Take a look at the graph. We know that this is a maximum value because our graph is opening down. So I'm going to use my calculator to find the maximum. Second, trace maximum. I'm going to start with my cursor on the vertex, or as close to it as I can get, and I go left 3. 1, 2, 3. Enter. Right 6. 1, 2, 3, 4, 5, 6. Enter. Guess. Enter one more time. It tells me the vertex is the point negative 1, 4, an x value and a y value. Range has to do with y values, so we know that all the y values are less than or equal to 4. Anywhere on this parabola, the y value is less than or equal to positive 4. Number 7, which of the following equations is represented in the graph above? Okay, this graph is going down. That tells us that the a value has to be negative. Okay, so I need the first number to be negative. That means already I can cross off C and D. These equations are in standard form, and when we are in standard form, ax squared plus bx plus c, the c value is the y-intercept. In our problem, the y-intercept is at 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means our c value has to be 9. Looking at choices A and B, the only one that has a c value of 9 is choice B. To double check yourself, you could graph this in your calculator. Make sure it matches. Choice B, negative x squared minus 2x plus 9. Take a look at the graph. And this does match what we have on our paper. So B is the correct answer. Okay, we are going to stop this video here and continue with number 8 on the next video.